Yes. Basically, the modified binders are required to counteract the heavy traffic or the heavy loading pattern, which is increased day by day, and the number of vehicles are also increasing. And to counteract this, we have to need different types of modifiers. And for basically, there are two main de-stresses, that is rutting as well as fatigue. These mainly occur due to the heavy payment, due to the heavy loading condition, and also due to the different loading axle loading configuration. And also, these are the distresses which forms or which is basically the key components of the design of flexible payment. Means the payment is basically designed on the basis of rutting as well as fatigue cracking. There are different types of modified binders, and dependability on the asphalt binder is mainly on the temperature, which influences the pavement stiffness. At high temperature, the rutting is more prone, whereas at low temperature the fatigue characteristics is more prone. You can say low temperature affects the thermal cracking, and the intermediate temperatures like 20 to 30 or 10 degree affects the fatigue cracking of the asphalt pavement. However, in India, payment are mostly designed by taking care of high as well as high and intermediate temperature, because low temperature like 0 minus 10 is sometimes we found in that higher regions, and that's why the payment is designed on the basis of intermediate and high temperature. And the modification of asphalt binder is basically to counteract this rutting and fatigue cracking which occurs on the pavement. And the modification technique also improved the cohesion, means it improved the adhesion as well as cohesion properties, like it avoid the stripping of bitumen binder and also resist in the weathering action. And the addition of modified binders may improve the performance even at lower as well as higher temperature, but there are many problems that arises with the addition of binder. First is the basically the cost of construction. Second, basically the problem that arises with the storage stability, because we have for the payment purpose we have to store the bitumen for a longer period of time. So there the bitumen is in a stable condition, and the modifier which we have added in the bitumen that settles down. This creates a problem, and that problem is associated with the storage stability. And also there is a lower aging resistance of that binder, because for preparation of the binders we have to heat the binder. Preparation of modified binders requires high heating temperature. That is why they are affected with the aging of asphalt binder. There are two types of modified binders. One is a polymer modified asphalt binder, other is a rubber modified asphalt binder. In polymer modified asphalt binder, we are having the polythene, ethyl vinyl acetate, styrene, butadiene, styrene. These are basically elastomeric thermoplastic and the plastomeric thermoplastic, or the waste plastic like HDP, LDP we are using. So in the rural road construction as well as urban road construction, people or contractor are nowadays encouraging to use waste polythene to go on the sustainable side, or to for a environment free construction, environment pollution free construction. So can you tell me the anything about the performance of waste polythene, waste plastic constructed roads? Any of your experience with the waste plastic or any modified binder?
Sir, here we have used plastic waste like LDP, HDP bags, cutted waste in
Okay.
roads. But that has created that we have observed the uh, damage caused to the surface due to water,
Okay.
resistance
Means
to damage due to water.
okay. Means there is a damage of means there is a stripping problem in that pavement.
No, sir, it has shown the properties of resistant to damage due to water.
Okay, okay, okay. And can I know how you have added the polythene in that binder? You have directly added it to the aggregates, or you have first prepared the modified binders, or you have prepared the binders for that?
We have added directly to the aggregate, sir.
Okay. So basically, there are two methods of addition of that polythene, and these methods are defined on the basis of the mechanism for which, or the construction work for which we have to use the modifiers. Like for the rubber and the polymer modified binders, for SBS, EVA, and crumb rubber, we are generally preparing the modified binders by using the high shear mixer, which I will tell later on. And there is one more technology nowadays which is a boom in the field of rural roads, is the nano modification. Are you working with the nano modification techniques?
No, sir.
Okay, because nowadays in rural road construction, people are using zycotherm as a nanomaterial. Initially, it was used as an anti-stripping agent, sometimes as a warm mix asphalt. Now they are selling the product as in the name of nano modification. So whether it is helping the performance in a nano level or not, that I just want to ask. If anyone is working with nano modification technique.
I have not worked, sir, but there's another site in Ladakh where they're still under this process, nano modification, but we are not uh, fully clear about its impact after 4 5 years or 10 years, sir. So
Okay.
no clear idea.
Means which nano modifier you have added in that?
Psychotherm, sir, I guess.
Okay, zycotherm only.
Sir, in Odisha, I have heard Terrazyme. They are using Terrazyme, but
Terrazine or Terracil?
Terrazymes,
Okay.
but its performance is very very poor.
Okay. Means they have used in the surface course.
No, sir, they are using in subbase layer.
Okay. I think
But
Terracil is
the
also a type
chemical
of.
availability is the
Uh,
yes,
yes, yes, yes.
chemical availability is the problem, sir. I guess in hilly areas.
Okay. Because that nano modification in the surface layer is upcoming, means is constructed nowadays. That is why more research is going on this part, on the nano level and the micro level. How by adding a nano modifiers or a small micro modifiers can improve the performance is a great challenge, or interesting to see also, whether it is working good or not. So I've seen many posts regarding the nano modification technique by TerraSil, Zyco Soil, Zyco Therm also. And Zyco Soil is basically added at a nano level in the soil subgrade to improve the performance, or as a stabilizing agent. Same as TerraSil, but nano that Zyco Therm is added to the surface layer. These are the modifiers. Some of the modifiers, like it is basically EVA, which is a plastomeric thermoplastic, and it is SBS, which is a commonly used elastomeric thermoplastic. And this is basically crumb rubber, which is we obtained from the waste rubber, waste tire. And as you can see, the modified binders, the elasticity is very high. Like he has only holded that material, and because of that flexibility and elasticity, it goes and goes up to a certain level by its own weight. And if it is this property can help us in providing good resistance in the fatigue, good resistance against the fatigue performance, where you will get a full rigidity and flexible structure. Therefore, modifier binders are generally used so that, because it helps in improving the high temperature performance by improving the elasticity, as well as on the other hand, it provides the flexibility as at the intermediate or the lower temperatures to counteract the rutting and fatigue respectively. What are the requirement of modified binders? Like the need, there are some requirements of the modified binders. Like for the polymer, the bitumen compatibility is very important. Compatibility means there are different types of polymers, whether they are compatible with the bitumen or not, we have to check. So for checking this, there the chemical composition of bitumen is totally different from the of the polymer binders, from the basic polymers. And there the addition of polymer may change the performance at the later period, like after 2 years or 3 years. And the polymer compatibility with one bitumen does not mean that the bitumen will be compatible with all the types of polymers. Like you can see in that images, that in the first image there is not any impurities you can see, or not any lumps you can see in all this picture. But here you can see there are small lumps. It shows the incompatibility of the polymer binders with that of a bitumen. This is basically due to the different chemical composition or due to the incompatibility. There are different types of binders. Like for VG30, we can use one polymer, like SBS is mostly used in India. And also there are rubber particles which forms lumps. So for that, we have to add some more additives to stabilize this type of polymers. The other requirement is the resistance to degradation. Like I have already told, it helps in providing elasticity at higher temperatures, and it can be processed by using the conventional technique. Like the same batching plant can be used for the modified binders also. So it reduces the cost if we are using the same conventional and laying technique, and it should be easy to coat and compact with the aggregates at the same temperature as that of normal binder. But it is not possible because addition of modifiers even include the high heating at high temperature, and for the preparation, because of high stiffness, we have to heat the modified binder at certain higher temperature as compared to the normal conventional binder. It should be homogeneous, like it should not show any compatibility issue, and it should be stable during the storage. Like I have told, that the storage stability changes with respect to the number of days. For example, it is shown that the storage stability of the compatible bitumen, like I have shown in the previous image, which is a compatible compatible image. It shows that the top and the bottom softening point is around same as that of means top and bottom shows equal softening point after 7 days. But you can see the bottom part and the top part in the incompatible bitumen, there is a huge difference between them. That is why the proper stability should be checked before using it in the construction work. And it should be resistance against stripping. Like one of the people told that the modified binders helps in resisting the moisture damage, and it is good against the moisture damage. Means the next question is how we can prepare the modified binders. There are different techniques of preparing the modified binders. Like I've told, you can add the waste plastic in directly to the aggregates. Also, you can add it directly to the binder, first to the binder, then to the aggregate. There are different techniques. So but the main thing is that the modifier should be thoroughly blended with the bitumen. It should show a homogeneous uniform composite when added in the normal binders. There are different types of modifiers, like I have told, requires different techniques of blending. The important thing is the storage stability. It should be stable after so many days of storage, like 5 months or 6 months. And the blended bitumen will be supplied in the tankers. So the modified binder is usually prepared with the help of a high shear mixer, which is generally rotated at a particular RPM, at a particular temperature, and for a particular time. These three things are basically important things which is used in the which is used to work with the modified binders. And the change in RPM, change in temperature, and change in time significantly affects the performance of the asphalt binders. The code which is recommended for the modified binders is IRC SP 53 and IS 15462, which shows the use of modified bitumen in road construction, type of modifiers and their advantages. It also includes the specification, application, and choice of appropriate grade, which has to be used at the site, and also tells about the method of testing the phase separations, like the storage stability issue they have also counted. And these are the types of modified binders. Like in plastomeric, there is a polythene, EVA, and in elastomeric, it is ETP, SBS, and many others. Natural rubber as well as crumb rubber are used nowadays, but the main problem is again the storage stability. What are the tests on modified binders? Which test we have to perform to check the performance? The bitumen is already a complex material. After that, I told that emulsion is a high complex material, very complex material, and the modified binders in that term is a critical complex material which you have to work with, because there are even with the normal chemical structure like asphaltene resin, there is other chemical components which are added in the asphalt binder, like styrene and butadiene and ethyl vinyl. Many other chemicals are added, so which makes the structure complex to study. The tests which are conducted are penetration, softening point, ductility, flash point as well. But there is a problem of conducting viscosity test at 60 degrees Celsius, because the bitumen is too hard and it contains various modified fibers, like the pellets of SBS are not that much mixed at not that much compatible at 60 degrees Celsius. That is why viscosity test is not possible to conduct in the normal convention by using normal conventional techniques. The different tests which are conducted is the aging evaluation, because it is mostly affected by the aging as it is prepared at high heating temperatures. Other is the storage stability issue. In the previous session, you have seen that the storage stability is a basic issue for the emulsion part also. But the testing scheme or testing technique is different for both emulsion as well as modified binders. Third is the elastic recovery test. How much elasticity is provided by the modified binder is to be checked. And the complex modulus test, which is a new generation test which is conducted, or it is basically some part of the PG test, performance grade test, which is used to be conducted. Like in US, it is going on since 2006 or 1990 also they have conducted complex modulus test. So first I will start with the elastic recovery test. The elastic recovery test is basically evaluated by comparing the recovery of the threads. It is generally conducted in the same ductility machine, like we conduct the normal ductility test, and the specimen is elongated up to 10 centimeter deformation. In that ductility test, we used to elongate the material till it breaks, but in the elastic recovery test, the specimen is elongated up to 10 centimeter deformation for 1 hour at a specified temperature. Can anyone tell the specified temperature which is used to evaluate the elastic recovery, and why we are using that temperature? Okay. The specified temperature for this elastic recovery test is the 15 degrees Celsius. And this test is basically used to assess the level of modification and the elasticity in the modified binders. As I already told, that same ductility machine is used to evaluate the elastic recovery test. The apparatus which are used is ductility testing machine, briquette mold, same, thermostatically controlled water bath. And the new thing is added is a type of scissor for cutting the asphalt binder for evaluation of elastic recovery. In this, the sample is first prepared and conditioned as same as that of a ductility test. The test is elongated at a specified rate of 50 mm per minute at a specified temperature, say 15 degrees Celsius. And the sample is allowed to elongate till a deformation of 10 centimeter, means the machine is allowed to elongate the sample till 10 centimeter. So it will be like this. It is basically 10 centimeter. And after 10 centimeter, following 10 centimeter deformation, the specimen is cut into two halves. This specimen is cut into two halves from the middle. And then the sample is kept in the water. The sample is already in the water bath in an undisturbed condition for 1 hour. The sample which we have cut is kept under the water bath and for 1 hour without disturbing. And after the specified time, the elongated half of the specimen which we have cut like this, it will be like this now after some time. But that elongated half of the specimen is moved back, means the scale is moved back, and we have to see where the distance where it again rejoins the binder which we have cutted. So the elongated half of the specimen is moved back to the position near the fixed half of the test specimen. So the to see the both specimen touch each other. And the length of the recombined specimen is noted as d centimeter. Before it is 10 centimeter initially, And after that, after rejoining, it will be d centimeter, and the elastic recovery is then calculated as 100 into 10 minus d upon 10, means if you put the value of d, the length of the rejoined specimen, you will get the elastic recovery part. The application of the elastic recovery is that it is suitable to evaluate this test is suitable to evaluate the performance or suitability of the modified asphalt binders, and the modified bitumen with low elastic recovery tends to crack. These are the values which are given in IRC SP 53 for elastomeric, the thermoplastic modified binders. The elastic recovery at 15 degrees Celsius is about 75%, minimum it is, and for the crumb rubber it is about 50%. But this test is not basically given for the virgin binders like VD 10, 20, 30, 40. Can anybody tell that why this test is not recommended for normal conventional binders? Okay, it is because the elasticity of the conventional binder is very less, which we can easily test from the normal conventional binder, conventional test like softening point. We can see the suitability of that binder. That is why the modified that elastic recovery test is not conducted on that type of binders. The second important test is the separation test. In the separation test is used to evaluate the phase difference in the bitumen at the higher or elevated temperatures. The method can be checked by using a softening point test. It is somewhat same as that of the separation test which is conducted for the emulsion part, but the temperature and the time is somewhat different. For the phase separation is basically a common problem, as I have already told. Either is elastomeric, rubber, nanomodified, which are available in the powdered form. It is a basic problem. That because of that different phase, it provides inappropriate performance. The apparatus which is used are the ring and ball apparatus, test apparatus, water bath, stopwatch, thermometer, and the burner. And these are the aluminum tubes which we have to prepare for checking the phase separation test. In this test method, first we have to prepare an aluminum tube with sealed end. Like we have to seal the end at the top. We have to seal the end at the top, and we have to heat the sample carefully until it is poured uniformly, and that too at a lower temperature, not at a very high temperature. Like the same, we have to avoid the overheating of the bitumen sample. And after thorough stirring, we have to 50 gram of sample is required to fill in that aluminum tube. And after filling, we have to seal the excess length of the aluminum foil and close the upper end. Means after this part is already closed. After filling the bitumen, we have to close this part also. And we have to, after closing both the parts, we have to place the rack in the oven at a temperature of 163 degrees Celsius for a time period of 42 hours. And this is basically a research work which is conducted, that they evaluated the heating at 180 degrees Celsius for 72 hours. Means you can check for different hours also to evaluate the performance at even more high temperature and more high duration. And after 48 hours, you have to keep the rack which is containing the samples in a freezer at 6.7 degrees Celsius. It is also specified in IRC SP 53, and this is kept in freezer to solidify the material which is in a liquid form. Thereafter, the tube is cut from the top part as well as from the bottom part. And after the cutting, both the parts are kept in oven at 163 degrees Celsius to remove the aluminum oil which is foiled over the surface of bitumen. And then the top part is evaluated with the softening point test, and also again at the same time, bottom part is also evaluated for the softening point test. And the report, we have to report the difference in degrees Celsius between the softening point of top and bottom section. As per the IS code, the difference should not be less than 2 degrees Celsius for a uniform stable material. However, these values are now changed in the new code. They have given like 3 degrees Celsius and 4 degrees Celsius for different types of binders. And the other test is the aging of asphalt binder, which is also a big problem. The aging basically defines the change in the properties with the time as well as temperature. There are several methods which affects the aging of the binder, or which is used to show or identify that which are responsible for the showing the aging properties. Like this is the mechanism of bitumen aging. It can be due to the oxidation, photo-oxidation, volatilization of the materials. And there is a chemical interaction also due to the time and temperature which is where the bitumen is subjected. Or due to the exposure of bitumen in the oxygen, sunlight, it affects the aging properties. It is affected at the surface as well as it affects the mixture performance also. As I can see, as I can told that there are many factors, and these are among the 15 different factors which are responsible for the aging of asphalt binders. Aging mechanism can be of short-term aging and long-term aging. Can anyone tell about the difference between short-term aging and the long-term aging? Aging generally occurs in normal binders also, like in conventional binders. Aging is a big problem, but for the modifiers, it is a very big problem. Can anyone tell what is short-term aging and when it is occurs and why?
Sir, short-term aging occurs during mixing, transport, compaction, and construction at site, and long-term after some times due to change in temperature, as you
Yes,
said.
yes. So the short-term aging is basically short-term aging is basically occurred during the laying, production, as well as the construction or compaction of the asphalt pavements. And the long-term aging is basically occurred after 5 to 10 years of the pavement construction. Short-term aging is checked by two different methods, that is thin film moment test and the rolling thin film moment test. And for the long-term aging, pressurized aging vessel is used. So for the short-term aging test, the method wording includes the thin film oven test, where we have to take 50 gram of sample in a cylindrical bottom plate. This is a cylindrical bottom plate where we have to add the binder, and it is rotated at a speed of 5 to 6 revolution per minute. And the test is conducted for 163 degrees Celsius and 5 hours. Can anyone tell why it is taken 163 degrees Celsius is selected for finding the aging characteristics? Just now, someone have told that aging occurs at the mixing, compaction, and laying of asphalt mixture. So basically, 163 degrees Celsius.
Actually, it is the mixing temperature.
Yes, means it is the average mixing temperature which is taken which is taken to test the aging characteristics of the asphalt binders. It simulates the short-term aging of the thin film of bitumen during the production to compaction. And the change in the physical properties and rheological properties are assessed to get the effect of aging. There are different types of physical tests and rheological tests that has to be conducted after the aging of the asphalt binders, to check the performance after some years. Like for long-term aging test, long-term aging samples, we have to check whether how it performs after 5 to 6 years. And for short-term aging, we have to check whether the condition of the sample after the construction compaction part. The method 2 is rolling thin film moment test. It is also simulating the same short-term aging of the asphalt binder, but it takes less time. In this method, 35 gram of sample is taken, and it is kept in a glass jars, which is like the glass jars are like this, We have to fill the material, 35 gram of material in this, and we have to put this glass in the rotating wheel. It is rotated at a rotation per minute of 15 rotation per minute with an airflow of 4,000 ml per minute. It is basically the improved version of the thin film movement test, and it takes the shorter duration because it is subjected at 163 degrees Celsius for only 85 minutes, where it is 5 hours for that thin film movement test. And it is given in ASTM D1754 and ASTM D2872 is recommended for rolling thin film movement test. For the long-term aging condition, PAV is used, and it is generally conducted or tested upon the RTF4 thin film age samples. In this method, we have to heat the binder for a time duration of 20 hours at a temperature of 100 degrees Celsius to simulate the condition of the binder after several years. A gradual release of the pressure is required. A pressure is required to simulate the field condition, like the binder is subjected, our pavement is subjected to different pressure, different chemical different temperatures and different climatic conditions. To simulate the same thing, we have to release a gradual pressure on it. And after the removal, we have to place that in the plate in the 163 degrees Celsius for 15 minutes for the scrapping of the binder to test for further investigation. And similarly, we have to place it in a vacuum oven, like for degassing of the entrapped air. What does it simulate? Like one told that it simulates the heat and pressure condition of the pavement after 7 to 10 years of period. Last part or last test of which is conducted on the modified binder is basically the complex modulus test, which is now recommended in IS 15462 that there should be a value of a complex modulus, minimum value of complex modulus, or you can say rating parameter or fatigue parameter. This is basically the rheology is basically the combination or the science which deals with the flow and the deformation part. It is generally conducted with dynamic shear rheometer. It is a very expensive and a complex material, instrument, which is also available at IIT BHU. Now we are having two MCR 102 and MCR 302. It basically applies a sinusoidal stress and strain. The stress and strain is applied in the form of sine wave, and I will show you the details of the sample in the next slide. And in this test method, we generally measure the torque and the angular rotation. And these values of torque and angular rotation are used to evaluate the mechanical properties on a micro level. The torque and the deformation is used to evaluate the complex modulus G star, which is the ratio between the maximum stress and strain. And the phase angle is also evaluated, which is basically the time lag between the stress and the strain. This is basically the sample size. You can see a very minute level of very minute dimension of binder can tell us the performance of the rolled pavement even after the 10 years of construction. Like we are using only 25 mm diameter specimen with a 1 mm height. You can think that it is a very small binder, even 2 grams of 1 gram of binder, which can tell us about the performance of 5 years or 10 years or many years after the construction. It captures the effect of the DSR basically captures the effect of time and the temperature. In this test, the value of G star by sine delta and G star dot sine delta, which is said to be the superpave rating as well as the fatigue parameter, is determined to evaluate the rating and the fatigue characteristics of the asphalt binder at 10 to 70 or 80 degrees Celsius. This test method can be used for unaged as well as aged binder. That is why DSR is recommended, because we can test, and the specifications are also available for the aged asphalt binders, which can directly simulate the field conditions. The test temperature is directly related to the temperature experience in the pavement. For the at the places, the temperature is the that temperature where we have to use the binder, like if we have to use the binder where the temperature is 60 degrees Celsius, then we will directly check the performance at 60 degree in that DSR. But in the previous test, like penetration softening point, they given the temperature value that we have to check on that particular temperature, but it is not that same in the DSR testing. We can check at any test temperature. In this method, as per the code, the temperature is just determined corresponding to the value of G star by sine delta, which is a rating parameter. The value should be greater than 1 kilopascal in unaged condition, while it is 2.2 kappa for aged condition. And this test is basically used to evaluate the performance, where the elastic recovery test does not give any significant value, because there are many binders which are showing different performance at different temperatures, and the elastic recovery is not that much high for that modified binders. Then the DSR testing is recommended. These are the maximum atmospheric temperature limits which is given by the IS code. Like if the temperature is less than 35 and greater than 10 degree, then you have to use PMB or NRMB 70 and CRMB 55. In this, the 70 is basically the penetration value. Like in PMB, NRMB, and other binders, the 40, 70, and 120 basically indicates the penetration value. But for the CRMB case, they have specified the binder on the basis of softening point. Like CRMB 55, basically the maximum temperature, maximum softening point they have recommended. Like 55 degree is the softening point for this binder. Similarly, for CRMB 50 is the softening point for that binder. These are the specifications they have given for different types of binder. Like type A is used for the plastomeric thermoplastic. For EVA type of binder, you can see they have included the complex modulus test in this. For more complex binders, they have specified the value of G star by sine delta, that is minimum 2.2 kappa at 10 radian per second. We have to find the temperature in this. Like it can be suitable where the temperature is 52 degree. PMB 70 is suitable where temperature is 58, and PMB 40 is suitable where the maximum temperature is 70 degrees Celsius. Similarly, this is for the aged condition. For the unaged condition, they have provided the same thing corresponding to 1 kappa values. And also for the plastomeric elastomeric binders, they have again provided, they have not provided that complex modulus values, because elastic recovery value can be suited in this type of modified binders. So, however, it is not suited for plastomeric binders like EVA and all. Similarly, for NRMB and for CRMB, they have not shown the complex modulus values, but in the upcoming codes, I think it is a good method, or it is a vital tool to evaluate the performance, because it is directly giving the temperature, at what temperature we have to use the binder, or at what temperature the binder is not suitable. So I think it is the best method to evaluate the performance, even at lower as well as higher temperature, and that too by using a small binder. We are not wasting our binder in testing. Like we have to take 50 gram of binder for the penetration test. In this, we have to take only